question 1, we've got to draw an ordered stem and leaf diagram for the information given. So let's do the stems first. So we'll have 2, 3, 4, 5 and 6. You haven't got to be too neat with this, you just got to get it so it's easily read. And then we can take some of these off here. So we've got 28, 51, 42, 23 and 63 and so on. Takes a bit of time to do this. Okay, and then what you can do is you can do that in small, it's up to you, and then I just basically do it again. And so you can have your stems the same. And then you just got to put it in ordered. So for this one here, we'll have 3, 5, 8, then 9. Then here, 2, 5, 7, 8, 9. And then 1, 2, 4. A 1, and then 1 and 3. So this is how the final outcome should look like, and that's an ordered stem and leaf diagram. And we're going to have to draw a key as well. So we could say, for example, that 2, 3 drawn like that on the stem and leaf diagram, that would be the same as a length in centimetres of 23. Okay, so that's question 1. So question 2, a delivery driver records for each delivery the distance he drives and the time taken. The scatter graph shows this information. So what have we got to look at here? Well, it says that for another delivery he drives 22 kilometres and takes 50 minutes. Show this information on the scatter graph. So we want to look at 22 kilometres and 50 minutes and make sure we get that accurately shown, like so. The next part of the question, well, that says, what type of correlation does the scatter graph show? Well, for me, this would be a good opportunity to draw the line of best fit, because visually that would give me quite a few clues as to what was going on here, and I can see that nearly every single part of the data fits nicely to that straight line. The only one that doesn't is this one, which is an outlier. And an outlier just means a piece of data that doesn't necessarily fit with the vast majority of the other data points, but we'll come to that later on. So what type of correlation does the scatter graph show? I personally would say a strong positive correlation. So let's have a look. Correlation spelt with 2 R's, don't forget. Okay, well, what's the next part of the question asked for? If I can get this to work, let's have a look. It says the driver has to drive a distance of 10 kilometres for his next delivery. Estimate the time taken for this delivery. Well, let's have a look first of all at the distance. There's 10 kilometres, and I would use a ruler here in my exam, as I hope you would too. Show the estimate here using your line of best fit, and then clearly here I would say 21, and I'd write that down in the answer part here, and I would say 21 minutes. Okay, let's have a look at the next bit. It says here, during one of the deliveries, the driver was delayed by roadworks. Using the graph, write down the time taken for this delivery. Now, one thing I will say is, and be very careful here, this has changed a little bit because I had to move this part here to see the other part of the question. And when I do that, everything moves. So don't think that's a mistake. So during one of the deliveries, the driver was delayed by roadworks. Well, it has to be here then, doesn't it? Okay, because I mentioned that earlier, that this was an outlier, i.e. a strange piece of data that didn't fit in with the others. So I would just say here, using the graph, write down the time taken for this delivery. Well, if it wants the graph used, then use it and just circle this part here, showing clearly that 45 minutes would be your answer. Okay, so that's question 2. Question 3, it says Ali is Y years old, okay, and Bavara is twice as old as Ali, so that would mean that Bavara would be 2y, or 2 times y, years old. And it says Ceres, or Cheris, is 3 years younger than Ali. So let's write that down here. I think the names are harder for me to pronounce than the actual maths involved, so I hope I've not offended anyone if that's your name. So Cheris, or Ceres, is 3 years younger than Ali, so you'd have y minus 3 here. It says the total of their ages is 125 years, and then you just got to work out the age of each person. Well, try and think a minute. If you've got all of these ages here, then you want the sum of these. So you'd have y plus 2y plus y minus 3 would be equal to 125. So we'd have 1y and 2y, that's 3y, and one more, that would be 4y, minus 3 is 125. And then from here, I would solve this linear equation and I would add 3 to both sides, which in turn would give me 4y equals 128. Then divide both sides by 4, and that would give me y equals 128 over 4. And it's a calculator paper, so you can use your calculator at this point. I'm just going to do it without. So we've got 4s into 12 is 3, 4s into 8 is 2. So we know that y, and I'm using the equivalent sign here, which is written like so. So that would be the same as 32. So y is 32. So Ali in this case would be 32. Bavara would be twice as much, which would be 64. And then here, Cheris would be y minus 3, which is 32 minus 3, which would be 29 years old. And if you added all of those up, of course, you'd get your 125, which was indeed the total. So slightly tricky in some ways. I just think what they were testing here is to know your expressions and knowing how if you had y for one person, that twice as much would be 2y and so on. That's the real test here. And a little bit on, of course, linear equations. Okay, so let's move on to the next question.